Okay, let's look at the piecewise defined functions. All right, so it's probably the easiest to kind of dive right into examples. All right, so piecewise defined function is a function with multiple personalities, which means that it has multiple formulas. All right, so for example, y equals absolute value of x. This is a hidden piecewise defined function because absolute value of x behaves like this, right? Depending on the x value, absolute value sign does different things. So for example, if x happens to be non-negative, right? So absolute value sign doesn't do anything. So absolute value of x is exactly the same thing as just x if x is non-negative. But if x happens to be negative, what the absolute value sign does is to negate it so that it becomes positive. So it's going to be negate x, so which is just a negative x. All right, so let's sketch the graph of this function. All right, so I'm going to just draw an x-axis here. All right, and a y-axis here. All right, so you just need to do piece by piece. Right, so let's look at the first one. Right, so y equals x. Right, if x is greater than or equal to 0. Right, so y equals x is just a straight line. Right, slope is 1, y-intercept is 0. So it's going to go through the origin. So it's going to look like this. So it's a straight line with slope 1 going through the origin. Right, and we get to keep this graph if x is greater than or equal to 0. Right, so starting from 0, we get to keep this portion of the graph. Right, for the second piece, y equals negative x, so slope is -1 and a y-intercept is 0, so it's going to be a straight line through the origin with slope -1. So it looks kind of like this. All right. We can keep this graph if x is less than 0. Right. So we get to keep this portion of the graph, and it matches up quite well. All right. So that's why the absolute value of x will have the V-shaped graph. Right, so but this is a kind of piecewise defined function. All right, so let's look at the second example, which is more general piecewise defined function. All right, f of x is 2 minus 2x if x is less than or equal to 2, less than 2. All right, x minus 2 if x is greater than or equal to 2. All right, so let's try to evaluate this function at certain points. Right, so f of -2. Right, so x is -2. Since -2 is less than 2, we need to use the top formula. Right, so you have 2 minus, there's a 2. Right, x is -2 in this one, so it's -2. Right, this is going to be, so 2, -2 times -2 is +2, so it's going to be +6. Right, if it's 0, 0 is still less than 2, so we're going to use the top formula again. So you have a 2, all right, then you have a -2 times 0, which is +2. Right, and if you do f of 2, all right, now 2 is not strictly less than 2. 2 is greater than or equal to 2. So now we use the bottom formula. So x is to 2, all right, minus 2 is going to be equal to 0. right? Then you have 5. 5 is certainly greater than or equal to 2, so you're going to use that bottom formula. So it's going to be 5 minus 2, which is going to be equal to 3, right? So that's how you evaluate piecewise defined function. So since there are multiple formulas given, so you have to pick the right formula depending on the given x value, right? So let's sketch the graph of this piecewise defined function, right? So let's look at the top one, right? Top, it's y-intercept is 2, and slope is negative 2, right? So start with that y-intercept 2, so which is right here, right? Then as you go to the right 1 unit, you have to go down 2 units since the slope is negative 2, right? So the graph is going to look like somewhat like this. So it's going down and going through that y-intercept there, and it looks like this. All right. Then we get to keep this graph when x is strictly less than 2. Right? So x is 2 right here. So from here, so since it's a strict inequality, we put the open circle here. Right? Then we get to keep the graph right here. All right? All right, then the second piece is x minus 2. So slope is 1, and the y-intercept is negative 2. So you go down to negative 2 right here, and slope is 1. So you guys, as you go to the right 1 unit, you can go up 2 units. So you can see that this is going to be the graph. All right, so like this. All right. Then you can see that we can keep this graph if x is greater than or equal to 2. So 2 is starting from here. Since there's equality, we should put a solid dot here. Then we get to keep this portion of the graph, the line, right? All right, so make sure that this is the right graph. Let's double check. So for example, when x equals negative 2, go up. Actually, it's we have to extend it. So this guy right here is going to be 6, as you can see. And when x equals 0 is supposed to be 2. So go to 0, which is right here. Go up here, so that's 2. So we got that. All right. And f of 2 is 0. So 2 is right here, and there's a dot here, which is 0. So that's right. And f of 5, so if you go to x equals 5, go up, and here, so that's 3 right there. So that works out. All right. So this is kind of how you evaluate the piecewise defined function. Just choose the right formula, then plug in. And if you want to sketch the graph of the piecewise defined function, all you have to do is draw it piece by piece and add the restriction of x. All right, that's it. I hope that this was clear.